Hello, today we are going to cover 6.8 graphing radical functions. You guys will be able to graph square root and other radical functions. The first thing we are going to do is we are going to discuss the general form, parent function, and then how we can graph these radical functions before we start. So we have the general form and a parent function here. So what we can do is we can take a look at these. So the general form is f of x equals a to the x minus h plus k. If you recall, this looks a lot like when we did parabolas, graphing those, and graphing other things as well. These all work similar. So we have our parent function y equals the nth root of x. You could have a cubed root, fourth root. The root can change. We're going to mostly do square roots, but other things as well. Reflection in the x-axis is when the a term is negative like this. We can also stretch if the a term is greater than 1, or shrink if it is a fraction between 1 and 0, this a term out front here. And then our translations, those are left and right, opposite of h. So if this is a negative h, you go right, that many. And up or down, it is k outside of the radical. So you'll notice here, h, left or right, opposite, and k the way you would think. So we have some steps here. The first step to graph each function is to look at the parent function, and then tell the domain or range after that. That's like step 4 probably. So we have step 1, our parent function here. I went ahead and wrote out our parent function. It is a square root function. So I just did y equals the square root of x. Now I was smart about my x terms that I plugged in. I picked perfect squares so that way I didn't get decimals for my y. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So I am going to go ahead and start by graphing that parent function. So I have 0, 0, I have 1, 1, I have 4, 2, and I have 9, 3. So this is my parent function. Notice I'll use that function a lot for all of these square root ones, so keep that in mind. That isn't the one we're trying to graph, though. We are trying to graph this 2 times the square root of negative 1 plus 3. So notice there is an a term. When there is an a term, you are going to multiply the y column by whatever that a term is. So now I'm going to go, once again, over 0, up 0, over 1, up 2, and so on and so forth. So over 0, up 0, over 1, up 2, over 4, up 4, and over 9, up 6. So that is a stretching of the graph. We are stretching it upwards like so. And then from here, step 3 is you are going to want to translate. So our new blue graph, we are going to translate. Notice we're going to go right 3, opposite of h, and up 1. So this point here, he will go right 3 and up 1. The next point will go right 3, 1, 2, 3, up 1. It's kind of like a slope if you think about it. This next point will go right 3 and up 1, and the last one will go right 3 and up 1. You kind of have to use your imagination on that last one. So that one will look something like that. Okay? So if you take a look, let's look at Desmos over to the right here. I have these typed out. There's our parent function, and our new function should look similar to the one we just did. Obviously it's a little different because we're zoomed out here and zoomed in on our own, but something to that nature. Pretty good. So now our domain is the x values, how far it goes from left to right. So we have all real numbers with x greater than or equal to 3. Notice our x values start at this number 3 and get bigger as they go all the way out here to the right. The range of our new graph is also all real numbers, but this is with y values greater than or equal to 1. Notice we start at 1, and then they keep getting bigger, 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 bigger as they go up to the top. So that is our range. Now we have another one. Notice there is a little typo here. This should be -1/2 versus times 2, because then it would just be the same problem. So we have our parent function once again, still on Desmos as well. The parent function is the original black, so 0, 0, 1, 1, 4, 2, and 9, 3. This time, instead of multiplying the y's by 2, we multiply by -1/2. So it might be nifty to go ahead and rewrite the table down here. Oops, 9, here we go. And then if we multiply these y values by -1/2 now, we end up getting 0, -1/2, -1, -3/2, which is just -1/2. And then you can graph these new, not translated, but shrunk graph. So 0, 0 still. Notice that didn't change. 1, -1/2, tiny, tiny. 4, 1. Sorry, 4, -1, I should say. And then 9, -1/2. Very small. The graph is definitely shrunk. And from here we translate that, so our new numbers right here, we'll go ahead and highlight our dots a little bit. We need to translate to the right 3 and up 1 again, so over 3, up 1, over 3, up 1, over 3, up 1. And once again, use your imagination. 1, 2, 3, up 1. So our new and final graph for the translation of this is the purple one. Once again, we'll look here, check it out. Notice how we did a very good job at keeping that just like it is on Desmos. We do need to state the domain and range once again though. So domain, we look at our x values of this purple graph. They start at They start at 3. So we have x greater than or equal to 3. I should say we still have all real numbers though. And then our y values, how far it goes up and down. This way, we start at 0.5 this time. I'm wrong. We start at 1 once again. So we have all real numbers with y's greater than or equal to 1 because we start at 1 right here. and then go down. Oh, I am so sorry. We have y's less than or equal to 1. The numbers get smaller. So we have y's less than or equal to 1. All right, now we do have 2 more just like this. We'll try to speed through them. We have our parent function once again. Go ahead and draw that table out. If you get good at these, you don't have to do that. Parent function is y equals the square root of x. Go ahead and graph the parent function. Also, you don't necessarily have to graph the parent function if you can really get it. It does still help me, though, visualize what's going on. Notice I have a negative a, which means I need to multiply each of these y terms by negative 1. And then regraph them, so I have 0, 0 still. I have 1, negative 1. I have 4, negative 2. And I have 9, negative 3. Notice it's just reflected across the x-axis, like so. And then we go ahead and translate those pieces, left 1, down 3. So from here, I'm going to go left 1, down 3. And this one, I'm going to go left 1, down 3. And then from the third one, I'm going to go left 1 and down 3. And from the last one, left 1 and down 3. And then this purple line is my new reflection. Let me actually try to draw that back in. And there we go. If we take a look, we can compare using Desmos our solution. And it looks pretty good here. Just like that. That'll be easier to see it. There we go. Sometimes our Desmos graph how many you go up and down at a time makes it look a little weird, but negative 1, negative 3, there we go. Perfect. So our domain and range, once again, is all real numbers for the domain, except we are now starting with x's that have to be greater than or equal to negative 1. We have this negative 1 here. It must be greater than or equal to that piece. And our range this time is y's that are smaller than this negative 3 continuing downwards. So y is smaller than negative 3. All right, and then lastly, we have a new type. We have a cubed root. So that means we have a new parent function. That is y equals the cubed root of x. This also means our graph will look a little different. So I'm going to choose x's and y's. I'm going to choose x's specifically so that they are perfect cubes, like so. Okay, so the cubed root of negative 8 is negative 2. The cubed root of negative 1 is negative 1. 0, 1, and 2, like this. And I will go ahead and graph the parent function. So I go negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, 2. So it's like a little swoop. We swoop it down like this. All right, so that is our parent function. Once again, we look for a, we multiply y's times any a thing, but there is no a term, so we are just translating here. So we go left 1 from the h term, and down 1 from the k term. So we will graph our final right here. We go left 1, down 1. We go left 1, down 1, left 1, down 1, left 1, down 1. So on and so forth. We do all of them. And you notice it just moves the little swoop, the cube root function, a little bit. And then we need to talk domain and range. We have all real numbers. It doesn't start or stop anywhere going left to right, so it's just all real numbers, or you could write that negative infinity to positive infinity. And the range, believe it or not, actually extends in a very long while to all the real numbers as well. So all real numbers, this is the y's negative infinity to positive infinity. And that is it for our graphing. Have a great day.